All right, here we're looking at section 10.1. Our learning targets for the section are find sample spaces, then we're going to be finding theoretical probabilities, and then some experimental probabilities and discussing the difference between these two things. So first, let's just look at sample spaces. So a sample space is all of my possible different outcomes. So that's what we're going to be looking here. We're looking to find all of my possible outcomes. So how many? And then list them. So I flip a coin and roll a six-sided die. So the first thing I know is when I'm flipping that coin, I can either have heads or I can have tails. Those are the only two possibilities when I'm flipping a coin. Then it doesn't matter what I flipped on this coin, there are six possibilities from this. Right? I can roll a 1, I can roll a 2, I can roll a 3, I can roll a 4, I can roll a 5, and I can roll a 6 on any of these. So I'm going to list these out. Right? So here is my coin flip. And here is my dice. Here's rolling my dice. I can either get a heads or a tails when I flip the coin, and then the dice I can roll a 1, 2, 3, 4, 5, or 6. So that tells me that there are 12 possible outcomes because there's 1, 2, 3, 4, 5, 6 there, and 6 here, so that's a total of 12. So now I need to list them out. Right, and I'm going to use abbreviations because I don't really want to write down everything. So one of the possibilities was a heads and a 1. Another possibility was a heads and a 2. Then I've got a heads and a 3, a heads and a 4, a heads and a 5, a heads and a 6. Then I also have tails and a 1, tails and a 2, tails and a 3, tails and a 4, tails and a 5, tails and a 6. So this way also tells me that I have 12 possibilities because there are 6 possibilities with the heads and 6 possibilities with the tails. So there's 12 possible outcomes, and then I've listed all of them just using the abbreviations instead of going through every single word that I would have to write out. So here, try these ones. Especially look at number 2 because I've got multiple different things that I can look at. So what we just did was we created a tree diagram. That's what this is called. It's called a tree diagram. So this is one of the ways that we can find all of the possible outcomes is using our tree diagram. So go ahead and try that same way here. So now we're looking at theoretical probabilities, right? This is our second learning target. So the probability is always going to be a number between 0 and 1. If we're talking probability, it's always between 0 and 1. It can be a decimal, a fraction, or a percent. It can be a 0 and it can also be a 1. So this is kind of my likeliness of this happening. Okay? So if it's a 0, it is absolutely impossible, it will not happen. And if it's a 1, it's a guarantee, it's a certain to happen. The closer the number is to 1, the more certain it is to happen. And the closer it is to 0, the more impossible it is to happen. So now let's look at our theoretical probability. So our theoretical probability is just looking whether at an event. Okay, so it's theoretically what's going to happen. So we know that the probability is the number of favorable outcomes over the total number of outcomes. Right? And the outcomes that we're calling for are considered our favorable outcomes. So if I'm looking at flipping a coin and I want to know how many times I'll hit heads, heads would be the number of favorable outcomes out of the total. So I can also write my probability as this P of A, right? Because my event is A and the probability of that happening. Let's look at an example of this. So a student taking a quiz randomly guesses the answers to 4 true or false questions. What is the probability of the student guessing exactly 2 correct answers? So the first things I have to do is I have to find the number of outcomes in my sample space, right? And I can use a chart, I can use a tree diagram, I can list all of my different outcomes, but first I have to find all the outcomes. So we used here C is correct and I is incorrect. So I can either have all 4 be incorrect or all 4 be correct, and then I can work my way in. So I can get the first one correct and then the next 3 incorrect. And I can just continue to move these letters till I have all of my possible outcomes. So then I'm asked for exactly 2 correct, right? So that would be these ones right in the middle here. So I can use those numbers to help me. So now I have to identify the number of favorable outcomes, which are the ones marked in this 2 row, and the total number of outcomes. So if I count, there are 6 in here, and there's a total of 16. So now I go ahead and find my probability. So the probability of exactly 2 of these being correct is 6 out of 16, and I can simplify that to 3/8. So I could also write it as a percentage, 37.5%. And I see that this is less than 0.5, so it's a little closer to 0, so it's not all that possible. It's not all that likely to happen. So I can use that to help me. So the first thing I always do is I figure out all of my possible outcomes, then I figure out which ones I'm looking for, and then from there I can find my probabilities. So we're looking at the probability of the complement of an event. So the complement of an event is all of the stuff that is not in A. So let's look at an example to make it a little bit more sense here. So when two 6-sided dice are rolled, there are 36 possible outcomes as shown, right? So here they did a lot of the work for us. Find the probability of each event. So the first one is the sum is not 6. So I could go through and I could count every single time that the sum is not 6 and figure that out. Or, since I know that it'd be easier to figure out how many where the sum is 6, I can find the complement there. So let's go ahead and find where my sum is 6. So it's right here, right? And I can continue going here. Those are all of my possibilities where the sum is 6. So now let's look. So the probability that the sum is not 6 is the same thing as equal to 1 minus the probability that the sum is 6. That's the complement. So I have 1 minus 5 over 36, which equals 31 over 36, or approximately 0.861. Okay, so now let's look at part B. The sum is less than or equal to 9. So again, I could count all of the possibilities where my sum is less than or equal to 9, or I can count all of mine where it's greater than 9 and then subtract it from 1, as written here. So the probability that the sum is less than or equal to 9 is equal to 1 minus the probability that the sum is greater than 9. So if I count this where the sum is greater than 9, I end up with 6 possibles. So I know that 1 minus 6 over 36 equals this 5/6, or 0.833. So now I've found the two probabilities that I was looking for without having to count every single option. Okay, so we can also use probability when we're dealing with areas. So if I throw a dart at the dartboard shown, I have to figure out what is the probability of me getting certain points. My dart is equally likely to hit any point inside the square board. So are you more likely to get 10 points or 0 points? So I have to figure out which one's more likely. Okay, so the probability of getting this 10 is going to be the area of the smallest circle divided by the area of the entire board, right? Because this is the area of the entire board is my total outcomes, and I'm just looking about the outcomes in my 10. So I know it's going to be pi times 3 squared, right, because the radius of my little circle was 3, equals 9 pi over 18, and I know that this square is because 3, 6, 9, and so I can find the area of my entire square. So it's going to be 18 squared. So I have 9 pi divided by 324 equals pi divided by 36, or approximately 0.0873. So that's the probability of landing inside the 10 area, the little circle. So now let's figure out the probability of getting a 0 is landing out here on the edges. So I have to figure the area outside the largest circle divided by the area of the entire board. So first I find the area of the whole circle, right, which is this pi times 9 squared, and I subtract it from the entire area of the whole board, because that tells me what's left over on the 4 corners. And then I divide it by the area of the whole board, which simplifies down to 0.215. So I see that this number is greater than, it's closer to 1 than my probability of getting 10, so I'm more likely to hit 0. We could figure out the probabilities of every single circle in here just using our geometry and finding the areas of those different circles. So our probability can be used in different geometric ways as well. So here are some more monitoring progress. Try them and see how you do. So now we're looking at experimental probabilities. We're looking at this third learning target. So an experimental probability is actually on repeated trials, right? So I have data from some trials that were done. Theoretical probability is a lot of coins and dice of like, what is possibly going to happen if I flip them? The experimental probabilities, once I've already done the testing, now what am I looking at? So my experimental probability is the number of successes divided by the number of trials. So let's look at this. So we're looking at a spinner. So each section of the spinner shown has the same area. The spinner was spun 20 times, right? So I actually did this experiment, so I know we're looking at experimental probability. The table shows the results. For which color is the experimental probability of stopping on the color the same as the theoretical probability? So first I have to figure out the theoretical probability. Okay, so the theoretical probability on stopping on each of the colors is 1/4. And I know that because they're all the same size, so they're all 1/4 of the big circle. So now I can use my outcomes to find my experimental probabilities. So I know that my experimental probability of red was 5 out of 20. The experimental probability of blue was 3 out of 20. Experimental probability of yellow was 3 out of 20, and green was 9 out of 20. So when I simplify, I see that this red was also 1/4. So the experimental probability of red was the same as my theoretical probability. So now we're looking at another example. This is example number 6 in your book. Sorry, this is example number 6. So in the United States, a survey, so here's a survey it's conducted, so I know its experimental probability of 2,184 adults age 18 and over found that 1,328 of them have at least one pet. The types of pets the adults have are shown in the figure. What's the probability that a pet-owning adult chosen at random has a dog? So that's a lot of things we have to deal with. So we see here that this data does not include all of these adults that were surveyed, right? It only includes the ones that had a pet. So I can limit that to the information that I'm given. So what is the probability that a pet-owning adult chosen at random has a dog? So let's look at my solution here. The number of trials is the number of pet-owning adults, right? Because I don't care about those ones that don't own a pet, because I'm told in my question that I'm dealing with pet-owning adults. Okay, so that's my trials. So a success is a pet-owning adult who has a dog, which from my table I see is 916. So now let's find the probability that this pet-owning adult has a dog. Was that 916 divided by 1328, which simplifies to approximately 0.69. So the probability that a pet-owning adult has a dog is about 69%. So here's your last monitoring progress. Go ahead and try these before you try your exercises. And let's look back at our learning targets. So our first one was to find sample spaces. And remember that a sample space is all of my possible outcomes for if I was going to test the situation. So then we looked at theoretical probabilities. Now theoretical probabilities are, I haven't done the experiment yet, so I'm just trying to think of what might happen. And then we found some experimental probabilities. We've already done these experiments or the surveys, and we take the data and we can find some probabilities based on that. So now that we've looked at all of these things and we've checked off these learning targets, go ahead and work on that homework for section 10.1.